Good morning, and today we're going to find the equation of the tangent to the curve. So taking it a little step forward from using the fact that we know dy by dx or f dash of x is equal to the gradient of the tangent to the curve. We're just going to take it that little bit further and find the actual equation of the tangent. Now we know that the gradient of a straight line is constant, okay? So the slope of a given straight line is constant. We can determine the gradient of a curve at a particular point by considering a straight line which touches the curve at the point. So we've talked about this already. And this line, if it touches the curve at one point, is called a tangent. So that's an example of what a tangent looks like, a line that touches a curve at one point. Now we know that the gradient of the tangent to the curve y equals f of x at a particular given point, x equals a, for example, is given by f dashed of x, and then substitute in x equals a, which would then be f dashed of a. And it's exactly the same as finding the rate of change of f at a. So to find the equation of the tangent to a curve, we're first going to use differentiation to find the gradient of the tangent, okay? So remember I said that the gradient of the tangent to the curve is one of the triggers for a differentiation question, because we know dy by dx is equal to the gradient, or f dashed of x is equal to the gradient at a particular value of x. And then we're going to use the straight line formula to get the equation of the actual straight line. We use the y minus b equals m bracket x minus a formula to get the equation. So we need to know two things about the tangent, just as we need to know two things about any equation of a line, any line. We need to know two things to get the equation. We need to know a coordinate, any coordinate, and we also need to know the gradient. And it's this part here, this gradient part, that's where we're using differentiation to get the gradient, because dy by dx or f dash of x at a specific value of x is the same as the gradient. So here's an example. Find the equation of the tangent to the curve y equals x squared minus 3 at the point x equals 2. So let's just try to remember what we need to find the equation of the tangent. The tangent is just a straight line, so we're drawing back to our knowledge from the straight line topic. The equation of the tangent to the curve. We need to know a full coordinate. Okay, what we've got here is half of a coordinate. We've got x equals 2. We need to know the other half of that coordinate, the y part of the coordinate. We also need to know the gradient. So to find the other half of this coordinate, we're going to find what y equals when x equals 2. Now we have an equation here, which is y equals x squared minus 3. So if we put x equals 2 into that, we will get y, what y is equal to, which is the other half of the coordinate. Okay, the other thing we're going to do is we're going to start here by finding the gradient. So we need to know the full coordinate and we need to know the gradient. Now remember, the gradient of the tangent, dy by dx, or if it's f of x is given, it would be f dashed of x. So the first thing we're going to start with here is what dy by dx is. Dy by dx equals 2x, and the 3 minus 3 disappears. So we've just got a 2x there. But dy by dx is the same as the gradient when we substitute a specific x value in. So we're now going to find out what dy by dx is when x is equal to, in particular in this case, 2. So we're now going to put 2 into the dy by dx function, which is 2 times 2, which is 4. Now what does that actually mean? That means that if dy by dx is equal to 4, then the gradient is equal to 4. So you must state that very clearly, that if you have worked out that dy by dx is equal to that number, you then state that means that the gradient is equal to 4. Make that really clear. So that's us now worked out one of the things. We know the gradient is equal to 4. And the other thing I started off by talking about was we have to find a coordinate. But remember, we're told x equals 2. And a coordinate is just made up of an x and a y value. So we've got the x already. And we're now just going to work out what the corresponding y value is. So you look for something in your working or in your question that has y equals or f of x equals, because f of x and y are the same. So we've got a y equals x squared minus 3. So if we put x equals 2 into that, we will get what y is equal to, and the y part is the second part of the coordinate. So we've now worked out that y is equal to 1. So that just simply means then, if we've got now that x equals 2 and y equals 1, that is the coordinate 2, 1. Alphabetical order, x comes before y in the alphabet, x is your first part of your coordinate and y is your second part. So we've now got the coordinate 2, 1. Now we've worked out that the gradient is 4 and the coordinate is 2, 1. So we now go back to the straight line topic and put it into your y minus b equals m bracket x minus a formula. So we've got our coordinate 2, 1 and our gradient 4. And it was asking you for the full equation of the tangent, so we now put it into the y minus b equals m bracket x minus a formula. Y minus 1 equals 4 bracket x minus 2. Just tidy it up. Bring your constants onto either the left or the right. So we brought our negative 1 over to the right to make it negative 8 plus 1, which is where the negative 7 comes in. And that's our equation of our line. Okay. So that's the equation of the line finished. But just to show you what I mean by that, this next part is not part of your answer. It's just to demonstrate what this means. Here we have the quadratic x squared minus 3. Now you can see that the line will vary depending on where it's to touch the quadratic ones. So we want it to be a tangent that touches at x equals 2, which would be a line going up like that. But it would depend on where it's to meet the quadratic. It would be a line sloping down the way if it was x equals negative 2. So it's the line that you can see here, and what we've worked out now is that the equation of that line is given. Okay, we've worked out that it was the equation we've just found. So we're now going to look at exercise 6J. Now we're going to do questions 1 to 8, but if we could just miss out 5B just now, okay? But questions 1 to 8 on exercise 6J. And as always, ask your teacher if you need any help. Take care and good luck.